Yeah, so in this question, this is basically a question that came in JE Advanced to 2025. But like I was seeing that the solution that has been discussed so far in the YouTube are like they're right, but like I personally find those solution to be a bit on incomplete. So that's why I thought to explain this question in a detailed way. Okay. So, okay, so to begin with, let's say this distance is given to be D, capital D, and this is the thing. So basically, let's say I consider any point P on the screen. So basically, what this question says that, this is a standard question on interference, and they have asked you to find out the shift of the central maxima. Okay, so, if you go there, so here last line says the due to the combination of the ways the central maximum shifts in millimeter with respect to the point O is given by. And one more thing, that the refractive indices of this B and A are given. So like mu B is 1.7 and mu A is like 1.5. Okay, so these two things are given, and also like some parameters over there is given, that this T is given, this L is given, and so on. So let's discuss that. So first we will do a little geometry to find out few things. So let's say this this xy, which is shown over here. Okay, so let's say this xy is equal to A and this yz is equal to T minus A. Okay, so these are few things I will like to note down first. Okay, and this is equal to my PQ, and that is evident from the diagram because these two blocks are identical, this block and that block are identical. So just PQ and this yz, yeah, zy or yz, whatever you call, this is T minus A. Okay, fine. So this xy is equal to qr. Okay, so these are few things that we need to keep in mind. Okay, so okay, fine. Now there is one more thing. Let's say this angle is theta, this angle is theta. So from the triangle, let's say this is P, so let's say this is R. So from the triangle RXY, what we can say, that this XY is A, so A by L is equal to tan theta, and that is exactly equal to the tan theta of this bigger angle. So yeah, so this is not R, this is, let's say my bad. Yeah, yeah, yeah. Okay, fine. So let's assume that this point is K. Okay, so from the triangle, yeah, yeah, from the triangle KXY, triangle KXY, we get this A by L is equal to tan theta. There is no doubt about it. But we can also from triangle X, sorry, let's say this is J. So from the triangle KJR, or what we get from triangle KJR, what we get is that this T divided by this JK. What is JK? JK is nothing but D plus L plus L. So this entire length is JK. So this is L, that is L, then D. So D plus L plus L. So A divided by L is equal to T divided by D plus 2L. Okay, fine. Now if you want to find out this A, so A is equal to L divided by D plus 2L into T. So this is something that we will require. Okay, so this L is given to be 1 millimeter, so this D is given to be 2 millimeter, so this is also 2 mm, this is mm, this is mm, and this T is in micrometer, so this is 12 micrometer basically. Yeah, if I'm not wrong. Yeah, yeah, T is 12 micrometer. Okay, fine. So from this calculation I will get 1 divided by 4, this is 3 micrometer. So the value of A is 3. So T minus A is equal to 9 micrometer. So this is something that we will require later. So now to solve any kind of problem, so this is a generic approach to find out the shift of any nth maxima or whatever you call. So let's say I consider a generic point P on this screen where the nth maxima forms. Let's say this is the point P. Okay, fine. So the basic thing is the following. So this is S2. So we need to find out this S2P. minus S1P. So I am denoting this is optical. So optical path between these 2 points, optical, yeah. So the difference between these two is the path difference at the point P. So I denote that path difference with delta. Fine. Okay, fine. So that is something that we need to find out. So what is this optical path? So optical path is the path traveled by the light ray that is emitting from this point S1 and S2. So this is the path difference between the two light beams that is being initiated at the point S1 and S2. Fine. So now let me write down this S2P first. So how can I write down this S2P? So sorry, S2P, yeah. Sorry, no, like this point, let's say I denote this point with something else. Let's say this is L. Okay, so yeah, because like I have made a mistake, I have denoted this point as P also, but doesn't matter. Yeah, so S2L optical minus S1L optical is the path difference at this any generic point P at any generic point L where the maxima or minima whatever forms. So I want to find out the path difference at any point on the screen. Fine. So now if you write down this S2L opt, what will this be? So this S2L will be S2P S2P plus this will be PQ. No, this will not be PQ basically. This will be yeah, this is B and A. Okay. So A and B is respectively this one. Okay, fine. So this is B, this is A. So this is very crucial point. So now for this S2L, basically what will happen? So this is S2P. S2P is this much. S2P is basically this much from here to there. Now because there is a medium, so the optical path will be mu B multiplied by PQ. That's it. Then this light ray also travels through this QR distance, so the optical path will be mu A into QR. And then this light ray travels through the vacuum, so optical path and geometrical path will be identical. So this is RL, yeah. And similarly I will have my S1L opt. Okay, I will write it down separately, don't worry. Now basically from here what we can play a jargon over here. So this is S2P plus PQ plus QR plus RL. So then mu B PQ minus PQ plus mu A RL minus RL minus S1L opt. This is delta. So don't worry, I just have added and subtracted this PQ and RL and there is a reason behind it. I will show you in a while. So now I will club these 4 terms together. So this is the geometrical path. This is the geometrical path. So this is the S2L geometrical, yeah. Why this is geometrical? Because if this guy wouldn't have been there, let's say this guy wouldn't have been there, and this entire thing is a vacuum. So if this theta angle is small, you can consider the bend over here. So this S1L PQ QR RL contributes to S2L geometrical, because like if the medium अगर यहाँ पे मीडियम नहीं होता तो क्या होता, तो लाइट वैक्यूम से ट्रेवल करता और सेम एग्जैक्टली यही वाला पाथ लेता, S2P then PQ QR then RL. तो उस टोटल पाथ को मैं S2L geometrical करके डिनोट कर रहा हूँ, because we will require this later. So this is the thing. So now this will be mu B minus 1 into PQ but PQ, what I already have a relation for PQ, so this PQ is T minus A, so I will write it like T minus A. Okay, fine, plus mu A minus 1 into RL. What is RL? RL is like A. No, no, I have made a mistake. Yeah. So this is QR only. Okay, this is not RL. This is a bit of mistake by me. So this is mu a into QR, right? This will be follow from this step only. So minus QR. Okay. So this is QR minus S1 L opt, and I will write this delta on this side. So delta will become this. Fine. So delta will become S2L geometrical plus mu b minus 1 into t minus a plus mu a minus 1 into a, because this QR is a, which is followed from this equation number a. Okay, fine. Yeah, okay. So let me clear this thing once in a while, so then it will be easier to make you understand. So this is some raw folk that I was doing. Don't worry. Okay. So yeah, pardon me for this, small interruption. Okay, fine. Okay, fine. So minus S1L opt, right? So this will be S2L geometrical minus S1L optical plus mu b minus 1 into t minus a plus mu a minus 1 into a. Now I have to write down this S1L optical. So you remember this S2L geometrical is the path followed by the light ray, or followed by, I mean, whether it's a light ray or a geometry doesn't matter because there is no medium. So if this square box wouldn't have been there, so अगर वो नहीं होता तो जो path travel करता right ray, that is denoted by S2L geometrical. Like for that case, the geometrical path and optical path will be identical because the refractive index is 1. That's the thing. So now I will write down this S1L opt. Okay, fine. So give me a sec. Okay, fine. So now I have to write down this S1L optical. Fine. So what is this S1L optical? So from this figure is a bit messy right now, but like I will just carry from there only. So S1L optical is equal to S1x plus mu b into xy plus mu a into yz plus zl. So this is exactly followed from this equation. So first I will do with this path, then inside this material, this path, I mean this xy, then this yz, then zl. So that's it. Yeah. So again, if I play the same jargon, so it will be S1x plus xy plus yz plus zl plus mu b. Now mu b minus 1 into xy plus mu a minus 1 into yz. Now this is nothing but S1L geometrically, because like if there was no box there, so the geometrical path and the optical path would have been identical because the refractive index is 1. So now this is like mu b minus 1 into this xy is nothing but a plus mu a minus 1 into t minus a. Okay, got it? So this xy is, yeah, so xy is a and yz or zy is t minus a. So using this two equation, yeah, we are writing this thing. Fine. So now if I so delta was this. Now if I substitute this guy, if I substitute the equation for S1L opt, if I substitute this equation over there, then what will happen? Then my delta will become, like, let me change the color. So this black is a bit unattractive when it comes to teaching, otherwise it's good. So this is, so if I substitute this value of S1L opt over here, over in this equation, so this will be S2L geo minus S1L geo. There is a reason why I am collecting this term. There is a reason why I am doing this. Then plus this, if I club this term and that term and take the t minus a common, then I will get t minus a into this guy will come first because this is the part of S2L opt. So if I do that, so this will be mu b minus 1 minus mu a plus 1. And then similarly, if I collect this term, this term, this term, this term, this term, and this term, and take the a common, this will be so I have to subtract also, so that will come naturally with a minus sign, so this will be a into mu a minus mu b. Fine. So this plus 1 minus 1 cancel. Similar thing will happen in this bracket. So by doing the stuff, I am writing this. So this is geo minus S1L geo, geometrical, okay, plus t minus a into mu b minus mu a plus a into mu a minus mu b. Cool. Okay. Now there is a catch. So this is a generic thing. Whenever the things will come like this, you just follow the same prescription, whatever I am sharing. You'll practice this once or twice, and you will remember it for the rest of your life, I guess. Yeah. Fine. So this is delta. So this delta is, now focus on this term. So you see S2L geo minus S1L geo. So you just think about a situation. That let's say this is interesting. That's the reason why I have brought those terms. So let's say this is the situation, okay, and this is the center, and this is any point L over here, S1, S2. So this S1L and S2L geometrical means there is no medium in between. So this S2L geo minus S1L geo is something that we know already. Like we know this from the basic theory of our diffraction. So this is d if this angle is theta, or this angle is theta. So essentially this this S2L minus S1L geo will be d sine theta, right? Whatever you take this angle as 90 minus theta, or whatever, you take a component d cos theta, this guy is the difference. So yeah, so this two will be equal, so only difference will come from here, so that's d sine theta. If you take a cos component on this, d cos 90 minus theta, d sine theta, general story that we know. So this thing that we know, that will be followed, right? Because a geometrical path will be exactly equal to that calculation which we have done previously. Yeah. So now so this is d sine theta, right? So d sine theta is the difference between these two. So that is something that I know, so I will substitute. So this delta will become d sine theta. That's why I have added and subtracted, just to get this geometrical term whose calculation I am aware of. Yeah. So then this t minus a. So t minus a is yeah, okay. So t minus a, and what is my mu b? You see, you collect it from here, that your mu a is 1.7 and mu b is 1.5. okay, so this will be 1.5 minus 1.7, okay, plus a into 1.7 minus 1.5. So whatever, this d sine theta plus this t minus a, so this is minus 0.2 and this is like plus 0.2 to a. So if you take this point, so if you take this from here, if I do, so d delta is equal to d sine theta plus 0.2. If I take this common, a plus a minus t, something like this will come. So delta is equal to d sine theta, then this plus 0.2, and then you will get 2a minus t. So 2a minus t. Okay. So this delta. So yeah. So now I will make the thing. I will just recollect everything. So Now basically I will be focusing on this equation, yeah, this equation is something I will be focusing on. So following this equation, I will get delta is equal to d sine theta plus 0.2 into 2a minus t, or if I do, so this will be d sine theta minus 0.2 into t minus 2a. Okay, so that is something interesting. Okay, so now I have said that this L is a generic point, right? So this L is a generic point where the nth maxima comes. So if in this point L the nth maxima comes, so this delta will essentially be n lambda, because there is no other way. So this n is the order of the maxima that I am talking about. This is d sine theta minus 0.2 into t minus 2a. Fine. Now if they are asking about the central maxima, so that's why this n will be 0. So if you substitute this equation master, if you substitute n is equal to 0, so you will get essentially d sine theta is equal to 0.2 into t minus 2a. Fine. So this sine theta, so if this theta is small, so this sine theta and tan theta will be equal, right? So in place of the sine theta, you can also substitute dy 0 divided by d, because this theta will depend on this distance. So this distance I call like yn basically, but like I have substitute n is equal to 0, so that will follow, that will make this index 0 also essentially. Yeah, so this is equal to 0.2 into t minus 2a. Okay, so this y0, the shift in the central maxima from the actual center is nothing but this d divided by d into 0.2 into t minus 2a. Fine. Now what is this d? So this d is 2 meter. What is this small d? This is 2 millimeter. And then there's 0.2, and t is what? T is 12, a is 3, so this is 6, but the unit is micrometer. Cool. So this will be 0.2 into 6 micrometer divided by 1 millimeter. So this will be 1.2 into 10 power minus 3 meter. So this is the y0. So y0 is 1.2 mm. So the answer for this question will be this thing. So in millimeter they have asked, and you get 1.2 mm is equal to y0, the shift of the central minima or central maxima, sorry, not minima, central maxima is this y0. So that's the answer to this question. Thank you.